to set the tone. And we are at 105. So let's go ahead and get started here. Thank you, everybody, for attending our event today, Unlocking the Potential of Data in Retail. And today's seminar is going to have an emphasis and an actual technical demo on customer churn. So let's start with our agenda for today. So we'll go through some introductions of our speakers and our organization, Confiz. Then we'll transition into what is the value of data for retailers and brands, and a little bit more on customer churn, what it is, and why those metrics matter. Then I'll turn it over to Tom, and he'll talk about a modern data platform and a lakehouse first approach. And then that's when we'll go into our technical demo on predicting customer churn, and then we'll do Q&A at the end. So that will be our agenda today. So let's start with a couple introductions. My name is John Esmile. I've been in IT for over 35 years and working with customers of all sizes, from Fortune 100 customers to medium and small and everything in between. I've grown up in IT, and real focus of my last 5-6 years has been in the area of data. Been doing cloud initiatives for about 10 years or more, and who the real heart of today's presentation is Tom Robertson. Tom Robertson is a seasoned principal data architect. He has a world of background. And when I say seasoned, I don't just mean old, but someone that has lots of experience behind him. Who are we, and what does our organization bring to the table, and how does our background give us credibility to providing this webinar and presentation today? So Confiz has been around for over 20 years. In the U.S., we have dealt with Fortune 100 firms, some of the largest, or really the largest retailer, as well as some of the largest other brands or CPG accounts and retailers. And our industry scope goes beyond retailers and brands. We also have expertise in other industries, such as financial services, fintech, telecom, and really a subset of retail is the grocery or hypermarket business. We are a Microsoft solution partner in not only data, AI, and app innovation, as well as full service Dynamics 365 partner. While our organization deals with many different types of platforms, today's focus is going to be on Microsoft and Microsoft Fabric. A lot of these same concepts can spawn into other platforms, but today's focus will be presented and demonstrated in the Microsoft environment. So, how can retailers leverage data platforms for enhanced insights? Everything really revolves around informed decision making, right? Well, how can we harness this data and make better decisions? Whether it is working with customer churn or how to better keep customer retention. Could also be in inventory management, on-shelf availability, or just even inventory management. Do we have the right products in the right warehouses to be geographically dispersed so we can meet demands depending on the area? We'll use data to enhance our customer experience. Quite often in the retail environment, it's often what's that shopping cart experience? So you purchase the product. What products goes with that? So how do we enhance the customer's buying decisions to help predict what products they might also want with the current product they're looking at? All this can help bring better sales forecasting, right? So management can deal with demand. Should we open up new stores? Should we produce more products? So sales forecasting is really a valuable piece of data. So if you really look at it, that we say data is the new oil, right? So that the values in the data, and how do we harvest that data, and how do we use it to better put in platforms that will lead to better scalability and flexibility, and really spur innovation and growth. So let's talk a little bit more now about customer churn and where that comes into play. So customer churn is really the heart of it is when customers stop using our product, our services, and trying to discover why they start doing it. Churn rate is the number that we're looking at, and quite often we want to look at what are the patterns, what are the leading predictive indicators of why churn matters. So if we can build the next slide. Sorry about that, folks. We might have a little stuck. Okay, so keeping customers is really the heart of it, right? How do we do better looking at buying patterns when they stop using our products, and how we can better foresee what they might be needing in the future. And also customer churn could have other effects like dissatisfied customers. They could be dissatisfied with the product that they're buying, or they can be dissatisfied with the customer service with the product. Sometimes you're not going to lose customers if they buy something they're not happy, if you're able to deal with it quickly, send out a quicker return, replacement, make it easy for them to interact. So look at why customers are leaving you, and if the more answers you have, the better that you can do for it. Even looking at credit card information, right? So maybe you lose more customers that are the customers that have smaller shopping carts, where someone that's maybe more discriminative with their purchasing. Maybe you can even blend the data with income data. Do you do better with a certain level of income or people in certain parts of the country? So how can we harness this data to really understand why we're losing customers, so we can predict where it might happen and how we can prevent it in the future? So it all comes down to revenue, right? Dollars and cents. So we want to keep the revenue we have because we know customer acquisitions cost is way more expensive than customer retention. And not only do you have the tangible assets there, you have the intangible items like reputation and trust, right? So I think it was Warren Buffett says that it could take 20 years to build a brand and 5 minutes to lose it. So how do we keep those satisfied customers so that way we're keeping them and they're not inadvertently giving you bad reviews or spreading bad information of how they're unhappy with the customer? People tend to remember the negative more than the positive. So how do we keep customers from churning and eliminate that bad information, right? Like you could touch a soft pillow many times and be fine with it. But when you burn your finger on a flame, that negative reaction will sit with you a long time. So how can we use customer churn analytics to help preventing that burn? So how are we going to accomplish all this? The way we're going to accomplish this is with a modern data platform. A modern data platform is a highly integrated set of technology resources, services, tools, and processes designed to manage, analyze, and derive valuable insights from all types of data in a scalable, efficient, and extensible manner. Got to breathe there. That was a mouthful here, but that really encapsulates what a modern data platform is. So in boiling it down to a little bit more plain language is we'll take a modern data platform such as Microsoft's Fabric. We'll take all the data that we have from all our different sources. whether it's our store inventory, Yelp reviews, credit card information, bring it into one location so we can have better enterprise reporting and see what has happened, and then also land all that data in a repository so our data scientists can do our predictive analytics and really try to figure out what will happen in the future. And the more data we have, the larger data sets. And if we're constantly improving those data sets, we're going to improve our predictive analytics with better scores over time. And to get into the details of how we're going to handle that, I'm going to turn it over to Tom Robertson, and he will go through a detailed explanation. So thank you, Tom. Thank you, everybody, for joining us, and take it away, Tom.
Thanks, John. All right, let's start talking about data lakehouse approach and how it brings some benefits to retailers when gain insights from their data. So let's start with some of the key components and benefits of a modern data platform. And what we see here across the bottom are some supporting foundational capabilities that are common for all modern data platforms. We have scalable, flexible cloud-native products and services, and we use infrastructure as code. They provide a unified way to perform data governance and security, metadata management and data cataloging, and they encourage collaboration and support integrated workflows across teams. They support batch and streaming data, so data from any source, any type, structured or unstructured. They store that data in inexpensive, resilient, highly available cloud data storage that supports all data types, so in this case, blob storage. We have a storage layer that provides a container for data integration and curation so that we can create a single source of truth based on clean data. They provide us a way to do transformations and aggregations against that data to create a highly performant data analytics environment. They provide BI tools to provide modern reports and analytics dashboards that support data-driven decisions. And finally, they use the same data and the same platform, an architecture framework to support machine learning and AI solutions. So Lakehouse architecture was developed as an open source framework that combines the benefits of warehouses and data lakes. And here's just a quick description from or definition from Google Cloud Platform. I picked on them today. A data lakehouse is a modern data architecture that creates a single platform by combining the key benefits of data lakes, large repositories of raw data in its original form, and data warehouses where we have organized sets of structured data. Lakehouses enable organizations to use low-cost storage and store large amounts of raw data while providing structure and data management functions. So let's get into looking at what comes with a data lakehouse. We have an open storage format that supports any type of data, really, and there are no proprietary vendor-specific formats, licenses, or limitations to this format. Example formats include Parquet format, column separated value, XML, JSON, etc., all of which are open formats. Lakehouse architecture decouples compute and storage layers so that we can tune them efficiently independently of one another. They allow different compute configurations based on the workload requirements at hand. They effectively manage storage and compute layers in separate clusters, and the design provides the flexibility to scale solutions to support many concurrent users, perform complex computations, and run against larger data sets. One of the key features of a lakehouse architecture is that it provides transactional support. A data lake does not actually have this. This is where the lakehouse architecture really comes into play. And this provides atomicity, so each transaction is independent. It provides consistency, so that you seem to see data at that point in time that is not corrupt and there's no errors in your data. It provides isolation and durability. Lakehouse architecture also provides schema enforcement and evolution, meaning that you can define the columns and data types of your data, and that you can actually change that schema over time as you modify tables to accommodate new data elements. Lakehouse architecture also supports a wide variety of data types and workloads. So we can work with structured data, we can work with unstructured data such as photos, audio, raw text, etc. We can do batch and streaming data, and we can do analytics, machine learning, and AI workloads all on one platform. They provide metadata governance and security. So the metadata layer manages and organizes the metadata associated with the data store and includes information about data, including schema definitions and changes to that data. Provides a governance layer where we can provide for the collection, integration, and organization of trusted data sets, and provides a unified catalog and analytics objects and the metadata associated with each object. And finally, we secure this data within the layer that manages access to the data, tracks who has recently accessed it, and provides a unified solution for data security that's consistent across all the data sets. So what does this look like when we kind of put it all together? And here's a reference architecture that shows a lakehouse architecture. And on the left-hand side, you can see the different data sources coming into that architecture. So we have streaming, IoT devices, sensors. For example, with retail, maybe this is a footfall data stream that's coming in from your stores, showing how many people have entered your stores and at what time they entered. We can bring in structured data. So for example, ERP data. This will be relational database in a tabular format. We can do semi-structured data, text, CSV, logs, etc. And then finally, unstructured data, such as PDFs and images. We have a way to ingest data, whether it's coming in a stream or it's being ingested on a batch or a change data capture ingestion model. We bring that into the environment and we have an integrated solution where we can use Spark notebooks, SQL, and open source code in a collaborative manner. What you see in the middle is a Delta Lakehouse architecture, a medallion architecture, where we have bronze, silver, and gold layers. The bronze layer represents the raw layer of data. Silver is the filtered, cleaned, kind of augmented and curated layer. And finally, the gold layer is the serving layer, where we provide that data to customers and internal consumers. Across the bottom, you can see that we have a unified data governance solution to help manage all this data. And this platform is supported across all hybrid cloud providers such as Azure, AWS, and Google. We have SQL endpoints so that people that are familiar with SQL can access the data and work with it in a manner that's similar to a data warehouse and they're very comfortable with. And we have a data science layer where we can work in a code environment and perform experiments, AI, and ML. And we can report on this data from the reporting and BI layer. So what does this mean to us? When we bring this all together, we have data sources shown on the left here. And you can think of data warehouses, your on-premise systems, SaaS applications, machine logs, et cetera. And we have this need to ingest this data across many different platforms that you see on the left. And it could come in a form of streaming. So we show Kafka streaming. We've got event hubs up here, et cetera, and different layers of cloud storage at the bottom that you see there. And all of this, we need to bring this data in to unlock the value that's trapped in the data. And we can use BI tools against it to assess the data as soon as possible. We can obtain data for use in ML and AI solutions such as predictive analytics. And we can rely on data to automate actions and take do real-time dynamic pricing, fraud detection, alerts, et cetera. Couple just real quick. So there are several providers out there that provide packaged lakehouse solutions, one of which is Databricks. And you'll see here, this is their kind of diagram that they usually provide that shows the data warehousing, data engineering, and data streaming and data science personas, workplace personas, if you would, and then a unified catalog or way to govern the data across the environment. The Delta Lake, which is the open source storage layer and layer that provides the lakehouse architecture, the organization of tables, et cetera, and the fact that this runs on all the major cloud providers. Another lakehouse provider, which is the one we're going to use in today's sample, is Microsoft Fabric. And across the top here, you see the different work personas, user personas, if you will, data integration, data engineering, warehousing, data science, and business intelligence, all built on a platform that's built upon AI assistance through Copilot, shared workspaces, universal compute, one layer of security, one lake, which is their storage solution, and it provides an intelligent data fabric. It's just a quick diagram here to kind of show a very high level architecture for machine learning. And on the left, you'll see streaming data coming in through event hubs and stream analytics that gets processed by a Synapse Analytics notebook and then stored in Azure Blob Storage and then passed on to Azure Machine Learning for interaction. And across the bottom, you can see historical data coming into that Azure storage blob too, that can be used through Azure Synapse Analytics and then sent to Azure Machine Learning. Machine Learning, pardon me. Here we have a diagram that's basically showing, we have this data that we need to get from the left-hand side of this diagram, API, structured data, unstructured data, cloud data that's perhaps on different cloud providers, storage layers. And what we're seeing here is a metadata-driven data ingestion solution. So we have Spark-based notebooks that are orchestrating the ingestion of raw data from these different sources. They're moving it to the raw layer and then processing it with Synapse data engineering notebooks, so Python code, which takes data from the raw layer, curates it into the silver layer, and then ultimately takes it from the silver curated layer and transforms it into the gold layer for analytics use in Power BI. And across the bottom at the right there, you see the Synapse data science machine learning layer, which can use data from either one lake location, the silver layer, the gold layer, or even the raw layer. But typically for machine learning, we want well-curated, nice, clean data that we've done some feature engineering in. And I'll talk about that in a minute. So one of the key elements to preventing customer churn is that we need to understand the drivers of customer churn, automatically identify at-risk customers who are likely to churn, define some thresholds for acting on that churn, and take immediate action to follow up. So to do that, we need to understand which customers are going to churn and what features of their characteristics are causing them to churn. So let's get ready for the machine learning experiments. And one thing that's really important for machine learning is that we have to perform some steps here. We have problem formulation. We've already done that. We want to look at predicting customer churn. So we're going to need to do some data discovery, discover the available data and its characteristics. We're going to have to select the relevant data for experimentation. And then we're going to do some processing against that data. We're going to do what's called feature engineering. We're going to process and transform the data into meaningful features. You can think of these as columns within the table that are the columns that are important to the customer's characteristics that might cause them to churn. So we're going to create those features. We're going to clean up that data to reduce noise. And then we're going to end up with curated data that's experiment ready. And then we're going to be able to do our machine learning exercise. So with that, let's get ready for our demonstration of machine learning in Microsoft Fabric using Spark notebooks. So I'm going to switch screens real quick here, pardon me, and I will bring up my environment. Give that a second to refresh. You should be seeing my screen now. And what we have here is I wanted to start with an introduction to Microsoft Fabric, just the basic screen that you get on the home page when you land in Microsoft Fabric. And what you see here is this is a kind of their unified work environment. And you see the work personas across the middle of this section here. So Power BI, Data Factory, Data Activator, Synapse Data Engineering, et cetera. And what I wanted to just quickly show you was that down here on the left, as we switch through these different personas, or as we click on these different personas, it'll bring up the interface for them. And there's a common look and feel across these user personas. So you see across the top the things that we can do. We can create new things like a lakehouse, a notebook, an environment, etc. And down at the bottom, you can see the different components that we've created. So you can see a workspace, notebooks, etc. Now, if I switch views, again, if I go into perhaps a data factory view, you'll see the look and feel is very similar, except that things at the top have changed. The actions that we can perform are based on our workforce persona. So in this case, since we're in Data Factory, we want to be able to create data pipelines and data flows, et cetera. So I just kind of simply show you how these different personas look similar. Here's the data science persona. So again, kind of the things that you can do across the top, and you'll note that they're more aligned with what a data scientist would do. So they want to build ML models, they want to create experiments, they're going to write code in notebooks, et cetera. So let's take a look at the data that we're going to use. And here I'm switching over. This is the data engineering persona that I'm in, and I brought up a lakehouse. This is my silver lakehouse, and you can see that I have the fact underscore churn table highlighted, which has brought up a preview of the data here, and you can kind of see what this data looks like within this table. That's just what I wanted to show, so you have some idea. You can visualize What are we looking at? And these are the features, right? So is a customer ordering, online delivery? Is it how often do they come to the store? Are they paperless billing? Do they have payments through electronic checks, et cetera? Pardon me, let me scroll back to left. Are they male or female? Are they a senior citizen, et cetera? So these are the features that we've engineered, that we've selected out of our base tables to create this data to bring into our machine learning experiment. And we're going to try to test and see, what's the most important thing to our machine learning. What we'll do here is we'll go over to our notebook. So this is within the data engineering persona again, but again, you could get to this notebook through any of the personas, really, data science, et cetera. What you're seeing is the notebook for Churn, and what we're going to do is we're going to load customer data in from the silver layer. We're going to accelerate data prep with Data Wrangler, and I'll show you that in a second. We're going to explore the data to understand the features that are available within it and any interesting patterns that we can identify. We're going to build an ML model, and we're going to track the experiments with ML flow, and then we're going to log the ML model in ML flow as well to track it. We're going to run some batch scoring on Spark against our model with predict UDF, and then finally we're going to store these predictions in a lakehouse delta table so that we can see the resulting data. And then I'm going to show a very simple report that shows you churn over time. So let's kind of go down through this. Here you see a graphical depiction of what I just described. So problem formulation, ideation, which is we want to determine if we can predict customer churn. We need to do some data discovery and pre-processing against that data. And then we need to get into the experiment and model phase. And we're going to prepare the data. We're going to model it, evaluate it. We're going to explore it again and see how it's performing. And then once we reach a point where we're happy with the performance of the model, we're going to operationalize it. Then we're going to be able to enrich our data. Uh, you can see there at the batch level and at the direct lake level. And then finally, we're going to be able to gain insight from it by doing Power BI dashboards and reports against it. So let's look at this process. What you'll see is some of the first steps are to install and import libraries. So we have a whole series of Python libraries that we're going to ingest or import into this notebook so that we can use them, which is really just pre-written code that we can leverage that's already out there, that's been tested and proven across industries. We're going to load data, our labeled data that we looked at from the Silver Lake House, into a Delta table and then into a Spark environment. So you can see here a simple command where we're just selecting everything from the fact churn table and bringing it into our environment. And then we're going to be able to start exploring and visualizing this data. And here you can see a view where we can not only look at the data in a tabular format, but we can also look at it in a visual format, right? So graphic. And what you're seeing here is the same data from the table that we brought into our environment, and we're kind of slicing it up and looking at it in a chart view. You can see some drop-down boxes and things that we can pick on the right-hand side of the screen. And this is a GIF that I've created that just runs over and over again to kind of show you the features of this visualization. Another way to do this to accelerate data preparation is with Data Wrangler, which is a really cool feature inside the notebook where you can visualize again, and you can go even more in depth. And we can prepare the data for machine learning. We can reduce the noise within the data. We can drop things like null values from the total amount column. We don't want it. We don't want rows that have no value in the total amount spent by the customer. We're going to remove the customer ID as well to anonymize the data. And we're going to work with the total amount, unit price, and tenure month. We're going to convert them from strings to numeric values so that we can do math functions against them. And here you'll see this is a view of the Data Wrangler, again, a GIF that kind of runs through the different options. You can see filtering here by clicking checkboxes. You can see us looking for null values and really visualizing the data and starting to understand what we have in our environment and how we're going to work with it. So this is all data exploration and preparation. Here's an example too at the bottom here on step 2 where we can wrangle data through code, and you can see a traditional tabular format of the data that's in our environment now and what it looks like as well. So after we've cleaned up our data and we've kind of gotten a good feel for what it looks like initially and just gotten ourselves accustomed to it, we can do some exploratory data analysis. We can identify the important features of the data and get a feel for which features we feel are going to mean something to this model. And what we can tell from this graph below is that customers over time, the longer you're a customer, the less we have churn. So as the length of time a customer remains with the company rises, we see a corresponding decline in the number of customers who choose to stop their service with the organization. So at the bottom left-hand corner, you can see clusters more tightly of the blue dots, which are the churning customers. And as you move to the left, you'll see increasing numbers of the orange dots, which are customers that did not churn as the number of months increase. So we know that, tenure month is going to end up being an important feature. We can also do some feature correlation where we're going to measure features and the relationship between two or more of them in a data set. And we're going to help identify the degree and direction of their association. So which features are having an impact on the churn and which ones aren't. And you can see them grouped together on the left side of this graph and then on the right side of the graph as they relate to churn. Then we're going to start building an ML model and we're going to track this experiment and run within ML flow. So we need to build a base model and we execute code to do that. We're going to apply some hyperparameter tuning to that model as well. So we run through this code. Then we're going to take the data and we're actually going to split the data into test and training sets. So we're going to have like 40% of the data for training or 60% of the data for training, pardon me, and 40% for the rest for testing. And what we're going to do is we're going to train against the training data, obviously. And then once we have that data, we're going to compare it against the test data, which already has the answers. We know whether the customer churned or not. And in this way, we're going to be able to tell whether the model is getting more accurate or it needs more work. Then we're going to build a final model. And in this case, we're going to use an open source boosting algorithm that's called Light GBM. And it uses a decision tree to perform its algorithms. And the algorithm is designed to be very, very fast and efficient. It's memory efficient, so it can handle large data sets, and it's used for both classification and regression tasks. And we're going to perform what's called model fit. And then we're going to move into understanding. Then we're going to move into understanding feature importance. So what's the most important feature within our experiment? And what we can see here is as we move down this list from churn probability and total amount, unit price, we see online delivery, payment method, billing, order status, senior citizen, et cetera. We can see which features are most important to predicting customer churn. As we scroll down here, we can also see where we're getting into evaluating the model with training and data and test sets. And then we can also apply a confusion matrix against this data. And this helps data scientists determine how accurate the model is and how it's labeling data. We're also going to do a function that's called AUROC for area under receiving operating characteristics curve. And we're going to do the area under the precision recall curve. And these are data science experiments or data science algorithms. And what we see here is a score, and a higher score is better. So this is how we help evaluate our model. Then we're going to define and set the experiment in ML flow. We're going to execute it. We're going to log and build that model in ML flow. And here you can see that it actually came up with a model called Cool Carrot. These models are named dynamically by Microsoft, and it does come up with some interesting names. We're going to run some batch scoring on Spark with predict UDF, and then we're going to store those predictions in the data lake in the lakehouse in Delta Parquet format. And here you can see across this tabular format what the data looks like that we're storing. And at the bottom of this notebook, you can see the simple command that we use to create a table named churn underscore predict data, and then write it to the lakehouse gold, our gold lakehouse layer for use. Now, if we move over to our experiment view within our data science persona, we can see some of the last runs that we did. This is one of the models we created. It gives you a runtime, when it started, the duration, et cetera. And this is from a previous run. You can click through here and see the features that were used within this run. and the actual importance of the features too as we train the model. And here you can see that online delivery, total amount, tenure month are some of the most important features of the model outside of whether or not we predicted the churn and the churn probability. And then finally, next I wanted to move over here to the churn predicted table within the Gold Lakehouse and just give you a quick look at what the data looks like within this environment. So this is the data that we wrote out to the table after we did our experiment. And I'll scroll over here to the left, pardon me. And what you can see is whether or not the last two columns, churn and predicted churn. So the churn is the labeled data that is the true data. Did this customer churn or not? And the predicted churn is what our model predicted. So you can see in some cases where you have a 1 and a 1, the model did very well. It predicted whether or not the customer was going to churn accurately. But the third row down, you can see where it didn't get it didn't predict it correctly. This customer actually did churn, and the model predicted 0, means false, so it wouldn't have churned. So the model needs a little more work. We would keep working on the model to get it as accurate as possible. And then finally here, I'll just show you a really quick view of the average predicted churn by tenure month. And what you can see here, what this is depicting is the shorter the period of time that a customer is with us, the more likely they are to churn. After they reach, 20, 40, 60 months of tenure, they're far less likely to churn as our customer, and they're likely to remain with our organization. That's a demonstration of machine learning with Microsoft Fabric. And with that, I am going to go back to John and turn it back over to him.
All right. Thank you, Tom. That was awesome.
Absolutely.
Really appreciate that. So, what we're going to do a couple things is first open the floor for Q&A. So, please, if you have any Q&A, I'm not sure if we put it in the chat here or the chat, but if you have any Q&A, please let us know, and we can certainly answer any questions. And then while the meantime, while you're thinking of your questions, for those of you that are out there, we do have a post-webinar survey that we would appreciate you filling out the survey and staying to the end here. We'll give you a chance to win some sort of prize. I think we have some Amazon gift cards or something to give out there. So, but go ahead and post your questions in the chat box here, and we'll happy to answer it. And we have a couple of ebooks too you could download if you want to grab these links. So it looks like we have a question coming in from Mujtaba. And if anyone else has some, go ahead, feel free to start typing. So that's a good one. Tom, I
Yeah,
think you take some training, so why don't you go ahead and
sure. Actually, one of the best places to get familiar with Microsoft Fabric and begin your training is on Microsoft's Microsoft Learn website. They have some fantastic courses out there that you can get started with. And you can also sign up under your email ID for a free trial Fabric account and get into the environment and start playing around. But I would encourage you to do both. Go out to Microsoft Learn, take some of those free courses, get yourself an account, a trial account on Microsoft Fabric and try it out. Kind of kick the wheels, drive it around and see what you get. There are obviously other places you can get training too. Udemy, different, training for cost, but I highly recommend starting with the Microsoft Learn environment.
okay, and let me just kind of dissect Microsoft Fabric a little bit for you. It might help some of you. So, Microsoft, prior to Microsoft Fabric, the products and technology were Microsoft Synapse, Microsoft Data Factory, Azure Data Lake. And really, what Microsoft has done is taken all the individual services of the Azure Data Platform and combined it into one software as a service portal. And this also includes Power BI. So in the past, you would buy capacity for Power BI, you would spin up your Synapse, you would add in the other services, had to create a network to assemble it all. So now Microsoft has moved all those services to one item called Microsoft Fabric. So really, to get started, you turn on Microsoft Fabric. So that's the easy part. It was kind of like for the people that are old on the call, it was C colon install. That's the easy part is getting the software up and running. But now it's how to utilize the service. So Microsoft has taken a lot of that away. Um,
Thanks,
so
John. I think we I think we have a few more questions here. So
yep, you want to talk about
so
platform maturity with
yeah, let's talk about platform maturity. So certainly Microsoft Fabric is relatively new, uh, to, and it isn't as mature as some platforms. Perhaps we'll pick on Databricks or call out Databricks at this point. Databricks has been around for years now. It has a little bit more maturity than Fabric, especially the integration with the machine learning libraries and label libraries and feature libraries, et cetera. But overall, this is Microsoft, so they're maturing Fabric very quickly. They come out with changes almost on a weekly basis, and it's going to do nothing but mature and become more robust as you go. Um, so especially what I would recommend, and you have in here, Zane, you're asking about customers are looking towards moving towards a modern data platform. If you don't have a modern data platform now and you haven't heavily invested in another unified kind of environment, I would say Microsoft Fabric is definitely something to look at as a first mover. If you already have an environment and you're doing things in Databricks, Microsoft Fabric could still come into play. As John was alluding to, it's very quickly deployed. It's easy to use. It has I think the learning curve for Databricks is a little steeper. I just in my personal opinion. So if you're looking for a way to rapidly get started with a fully unified environment that doesn't take much setup, Microsoft Fabric is a very attractive environment.
Yeah, let me just kind of though, I'm going to just build on this a little bit. The
Go for it, John.
maturity of Microsoft's data estate services have been around for a long time. So for a completeness of vision and maturity, Microsoft has gone through the move from SQL Server to SQL Server Data Warehouse to MPP to now they morphed it into that which was SQL Data Warehousing and then into Synapse and now Microsoft is the next evolution. So while Fabric has only been out for about a year, it's really that next evolution. And when you talk about maybe more advanced features from a data science standpoint, Databricks has some, but Microsoft Fabric also has the ability to use Spark, Spark clusters, Python, all within Fabric, but Databricks is a good complement. So it is one of the most mature data platforms that are out there. And then I'll let Tom talk about a couple of other things, but Copilot. So there's a couple different views of Copilot. Copilot has holistically in the Microsoft environment is the term used for all their AI products and mostly associated with LLMs. So where Copilot for Microsoft Fabric would allow people to more speak in regular English in and create sentences or even use a microphone to put in your requests or what you want. And then the LLM service will change it into the code that you need. But I'll let Tom um, and no, I'll just answer that one. Fabric is a pure cloud play. All of the most advanced data services are all cloud. Anything on prem is really being, isolated to more operational data stores. So whether you use BigQuery, you're using Snowflake, you're using Databricks, all those are cloud services. So Tom, why don't you go ahead and expand on Copilot and then
Sure.
data sources?
Sure. Yeah, that was a good description, John. Copilot's actually integrated pretty well with Microsoft Fabric. So there are a number of ways that you could use it. This one is about the training model. So you could, the question was about the training model. You can use Copilot directly within a notebook, a Spark notebook. So as John said, you could simply type in a request, ask it to perform something within the notebook, perhaps help you find the best algorithm for calculating or predicting customer churn, or giving you an insight about the data within the notebook for exploration and wrangling. You could also create when full disclosure, that simple report that I created at the end that shows you customer churn over time. I asked Copilot to create that report, and that's what it created. So I did really nothing on that report other than type in a request into the Copilot prompt and ask it about my churn predicted data and to tell me that average over time, and that's what it did.
Yeah,
So that's
and then
pretty cool.
yeah, and then really when it comes to Copilot is kind of like more the interaction within the different systems at that term. And then if you're looking to do LLMs, then there's Azure AI Studio and some of those items that are you trying to incorporate more LLMs into your work. So that would be another direction that you would look at. Um, and Tom could talk about the training, what data sources to use on the training
Yeah.
models. I mean, yeah, I mean it's
Sure, we can talk about that. So if you looked in the demo, the churn table that I had was actually an aggregation of data from different sources. So you had some customer data basically that told you characteristics about the customer, male, female, senior citizen, et cetera. You had some demographic information as far as your or geographic locations of the stores, demographics, whether they were large or small. And then you had some sales data, for that customer, how many products had they bought over time? What was the total value of their purchases? And then again, more characteristics about the specific things that customer had signed up for. So, are they a web customer? Are they a store customer? Do they get delivery, et cetera? So those are the different features that you pull from. So largely customer data, sales data, and then store data was what we used within our model. And those are typical of customer churn. In some cases, you would use website data, subscription data, because you can always do customer churn against subscriptions too. Am I losing subscribers to my service? Is a good example.
yeah, and just even credit card data can be used as well.
Yep.
There's a lot of places you can purchase data, integrate data, collect your own data. The one thing with Microsoft Fabric, it allows you to bring any and all data sources in. And then even our organization has created some IP around data ingestion into Fabric, which allows us to easily onboard new data sources and even deal with things like slowly changing dimensions. So as the data sources changes, we can provide some automation of how we ingest that data into your environment. If we didn't answer any of these questions, you could rephrase them or ask a follow-on question. We got Zane typing. Oh, we got Edward and Zane typing. We got a lot of questions coming in, and we're eagerly. Should I play the music again? Oh, okay.
Right.
Thank
Who can
you.
type faster? You're welcome, Edward.
Yeah, yeah. Copilot's great, and just integrating, and then um, another thing that to talk about when you're using Copilot or AI Studio, um, the difference between the Microsoft environment, what you can do in that ecosystem versus ChatGPT is you can create a completely closed environment. So let's say you're trying to do AI around some LLMs that you can feed only your data, make sure it's not getting data from anywhere else, and keep that proprietary data in your environment. And you can use that for your LLMs. So that way you have the privacy, that you're not feeding your data up into any public stores, as well as the return and answers are only coming back with your supply data. And that prevents things like hallucinations, where the general purpose ChatGPT could grab data from anywhere, mix it together, and you don't know sometimes if the outcomes are accurate. Is there a demo environment that we can use for pre-sales to showcase newer technology to our customers? Yeah, so that would be we would definitely need to an organization create it like what Tom did here. We have a he created a demo environment, spun it up, and that's what we use for you today. I don't know if Microsoft Fabric has any of those pre-built demo environments that they load up with Contoso data. In the past time, you can, I don't know, have you seen any pre-built Fabric stuff with Contoso data? If you, those of you know what Contoso data is. Um,
They do have some examples. They're not necessarily pre-built, but what you can do is you can sign up for a Fabric account, or even a free account, and then on the Microsoft Learn website, there are different GitHub repositories where you can download code to create different environments and experiments. Matter of fact, some of the content that was in this demonstration that I did came from the Microsoft website. And John's right. There are AdventureWorks examples from the Microsoft AdventureWorks database, which is a fictional retailer, and Contoso, which is a fictional importer, worldwide importer. So yeah, you can set that up. But Zane is asking about Fabric's USP.
okay, so Fabric's USP. I'm not. Could you just type what you mean by that term, and I'll continue to answer it. So if you're already on a Microsoft data platform, so whether you're using SQL for your operational data stores, or you're already on Synapse and using Azure Data Factory, Azure Data Lake, it is easy to move all those services from your environment into a Microsoft Fabric environment that is as one software as a services. In terms of price standpoint, let's see, products, or but in terms of costs, where does Fabric stand in comparison to AWS? So I'm going to say it's in line with everything. You got to remember, Fabric is many services all put together. So we're talking about dedicated Power BI environment with your data warehousing, with your data lake, and with your data ingestion. So the everything put together attributes to the price. Where Databricks in itself is a data engineering and data science tool, and then you would still need to couple in a data lake, storage. You might still want to use something like Synapse or Snowflake to handle your semantic layer, to accommodate that before you go to your presentation layer. So it's really hard to compare each item individually, but I could tell you the unique selling point of Microsoft Fabric is you have a complete end-to-end solution that is one item that you're working with. You as a data engineer, data manager, you're not trying to assemble that system together. And in the past, there was always the tend to do the best of breed, because really that was kind of what we were left with. And if you really look at what Microsoft can do, at holistically, it is the best of breed using Microsoft Fabric. But then again, you could use Snowflake and Databricks. There's other combinations. Snowflake and Databricks can land in AWS. It can land in the Google Cloud. So hopefully, and then if you would like a session to go into even more demos, we welcome any of you to contact us directly, and we would be happy to sit on a call and do some drill downs for you. So we'll have time. All right. So hopefully we answered all your questions today, but we are at time, so we're going to have to drop now. And we welcome all of you to contact us. We'll probably send a follow-up email. Thank you guys for attending. We appreciate everything, and I hope everyone has just an awesome rest of the day. Thank you, everybody.
Thanks, everyone. Have a great one.
Bye.
Bye.